Next topic is Hadoop PIG Part 1. We are going to talk about PIG in 3 different parts. So this is Part 1, and this is going to be our last topic of the day. These are the set of topics we are going to cover. First, we are going to learn what is and why PIG is useful. And then we are going to see how you can execute PIG statements. And then we are going to learn the concept of PIG Latin scripting language. We are going to see operators and functions that are provided by PIG Latin script. And we are going to see general structure of PIG Latin script. And then relational operators. And then we are going to see a few more PIG examples. What is and why Apache PIG? You can think of PIG as a platform for analyzing large data sets. And PIG is a platform that is made of 2 components. One is a language, PIG Latin. That is the name of the scripting language. And the other one is a runtime for running this scripting language. So PIG Latin, you can think of it as high level compared to MapReduce. You can think of PIG Latin scripting language is high level language, while MapReduce is a low level language. So PIG Latin is a high level data flow. The reason it's called a data flow is that each statement can be executed and you can get the result. And the result will be fed into the next script statement, PIG Latin statement, and so on. So that's the reason it's called the data flow, because data is being flowed as input and output for each statement. And it's a scripting language for expressing data analysis. Again, PIG runtime is also provided as part of the platform. It is the infrastructure for evaluating and running these PIG scripts. So PIG scripts written in PIG Latin are automatically converted into MapReduce jobs by PIG runtime. So underneath, MapReduce jobs are created by the PIG runtime. Okay. PIG scripts are much easier to create and run than MapReduce code. In fact, this is the reason why most people are using PIG instead of MapReduce. So PIG is designed to be used by data analysts without writing Java MapReduce code, so without the help of MapReduce Java developers. So PIG is widely used as an alternative to MapReduce. And PIG is extensively used in internet companies, Yahoo, LinkedIn, Twitter, Netflix. So let's compare MapReduce against PIG. Okay. So MapReduce is written in Java, while PIG is written in scripting language. And we are going to learn this scripting language in the rest of the presentation. MapReduce, you have to think in low-level map and reduce paradigm. And I'm sure some of you got confused about the map and reduce paradigm. It's not that easy to think that way. Okay. While PIG is, you can think of it as high-level abstractions. It's a lot more natural to write data analysis code in PIG, okay, compared to MapReduce. MapReduce is very hard to do useful things such as filtering, sorting, aggregation, joining, and splitting. So these are commonly used operations, but in order to do these operations in MapReduce, you have to write very complex code. While in PIG, it's easy to do filtering, sorting, aggregation, joining, and splitting. So PIG provides, in fact, the operators that do these kind of things. It's very, very simple to do these things. PIG also provides several sophisticated data types. So it includes tuples, backs, and maps. And we are going to learn these advanced sophisticated data types in PIG later on. So in general, people say, the PIG code is 20 times shorter than MapReduce code, with only slight the performance overhead. So in general, PIG is recommended to be used over MapReduce, mainly because it's simple to use. Now, if you compare PIG against SQL, SQL is the declarative language and it's a complete result for each query operation. So you create a complete SQL statement and you get the complete result. So it's pretty difficult to write SQL in a complete statement. While in PIG, it's a data flow language, as I said before, because data can be stored and dumped at any point in the pipeline. So basically, you can think of PIG scripts is the sequence of statements, and each statement will receive input and it will generate an output, which will be fed as an input into the subsequent statement. Okay, so it is called a data flow language for that reason. PIG use cases. So scaling, extract, transform, and load, ETL process is quite popular in an enterprise. Basically, you extract data from multiple sources and you transform it, and then you load into maybe the relational database and things like that. Okay. So when you need a scalability and reliability, then that's the time you can use a PIG. So PIG is again built on the top of Hadoop cluster, so it can take advantage of all this reliability and all the benefits of Hadoop can be realized in using PIG. Okay. So, scalability, reliability, usage of commodity servers. These are all provided underneath by Hadoop, and, PIG is basically using these features of Hadoop underneath. Analyzing data with unknown or inconsistent schema. As I said before in the beginning of today's presentation, the data type these days are very much unstructured. Okay, so PIG can load and filter and join, group sort, and aggregate large amounts of data that are unstructured or inconsistent schema. Inconsistent schema, so you can handle it. Okay. So we're going to see examples of this later on. Okay, so going back to PIG Latin language one more time. So again, it provides easy of programming because it provides high-level abstraction. So it provides high-level scripting language. And it lets you do complex tasks involving multiple data sets. Okay, interrelated data sets. So you can actually join, you can group, you can split. These kind of things involve multiple data set, and usage of this multiple data set is actually easy to do in PIG. Okay. Optimized implementation. Because PIG runtime is highly optimized, it might be in fact better to use a PIG if you're not really an expert on MapReduce. Code that you're going to write in MapReduce might not be as optimized as the PIG runtime. Which is creating a MapReduce code underneath. Okay. Another advantage of PIG is that it provides extensibility. So users can create their own functions called the user-defined functions to do special purpose processing. So basically you can create your own script language vocabulary for anything you want, loading, storing, all kinds of things. Anything that you do in the data analytics, loading data, storing data, conversion, all kinds of things could be actually written in your custom user-defined functions. Okay. Well, actually, PIG Latin language comes with a lot of functions already. So in general, you're going to actually use the built-in functions. But in some cases, you might want to create your own. Okay, and that's quite possible. And we are going to actually create user-defined functions in part 3. Okay. Okay, so that is basically a general concept of Apache PIG. Now let's see how you can execute PIG statements. So you can execute PIG statements in 2 different execution modes: shell execution mode or script execution mode. So PIG provides what is called the grunt shell. It is a shell inside this grunt shell. You can actually provide a PIG statement and then you can execute it. Okay, so it provides interactive shell for executing PIG commands or statements. The way you are going to start the shell is that if you just type PIG without providing script file, then it will start the shell. And within the shell, you can do some system level commands such as cat or ls and things like that. Okay. Within the shell, you can also execute scripts if you want to by using run or exec commands. So shell is typically used for development. In general, you are going to run your script in script execution mode if you have a script. So basically, you are going to say pig and you provide the name of the script file, then it's going to run that script file. Okay, so shell execution mode and script execution mode, and we're going to try both in our hands-on lab. Okay, so that is the execution mode, and there is another execution mode that we need to know, which is local versus MapReduce. Okay, so as you expect, as you have guessed, local mode is that it's actually executing in a single JVM and is using files in the local file system. Again, this is used for development. So in order to run your pig statement in local mode, you have to say pig -x local. And that's going to create an interactive shell in the local mode. And if you provide a file, the script file, then it's going to run it in the local mode, meaning it will use the local file system. The other mode is MapReduce mode or Hadoop mode. So in this case, it's running on Hadoop cluster, which means it's running on HDFS file system. Okay. By the way, MapReduce mode is the default. So if you say just pig, it will run it in MapReduce mode. Okay. Or you can say not map, pig. If you say just pig, it will run it in MapReduce mode. Or you can specify explicitly that you want to run it in MapReduce mode by -x, -x, and MapReduce. And that will generate, that will start the grunt shell. Or if you specify a script file, you can say pig script file or pig-x MapReduce script file. In that case, it's going to run the script file in MapReduce mode, meaning it will use HDFS file system. There are several ways that you can run pig script. So you can run pig at the command line. Okay, so that's something we're going to try first. Okay, the command line. Or you can use a Hue. So we have seen, we have some exposure to Hue in our previous presentation, right? Okay. Cloudera also provides what is called the Cloudera Live. Cloudera Live. So, if you want to actually run your pig script and if you want to upload your file to Cloudera Live, it's basically live, the website. You can, provide your data and then you can run pig script. Okay. So you can use this one if you have not installed your Hadoop locally. Okay, we are going to actually play around mostly with running pig in a shell or a script file at the command line. Okay. Okay, so what we are going to do first is we are going to write a pig script that does the word count. So in our previous presentation of MapReduce, we wrote MapReduce code, mapper code, and reducer code, and the driver to perform word counting. Okay, so in this lab, in this pig hands-on lab, we are gonna actually do the same thing, but write the code in pig statements. So basically, this is the code. Okay, you can see this is a lot simpler than the files that you have to create when in MapReduce mode. Okay, so we are going to learn each of these in a bit more detail in the hands-on lab. All right, so we're going to do exercise 1, running grunt shell, and exercise 2, we are going to run a pig script, and exercise 3, we are going to actually do it in Hue. Okay, so let's take a look at the hands-on lab documentation. Yeah, so this is the lab documentation that I have already opened. So we are going to try with a grunt shell. Okay, first let's actually copy. So let's go to the sample data directory of your hands-on lab. Okay, so go to. So I'm already in Hadoop PIG 1, so I'm going to go to sample data. Okay, so we have a few sample data. Okay, and we are going to copy a Tom Sawyer small text file, Tom Sawyer big text file into my data directory of HDFS. Okay, So so we just did ls is at least. So we're gonna copy Tom Sawyer text file. So you can see I'm using wildcard. So it's gonna copy Tom Sawyer big, Tom Sawyer small text file. Okay. So let me just copy this guy. Okay, it's copied. And let's just make sure we have those two files in my data directory. Yeah, so we have Tom Sawyer big, Tom Sawyer small text file. Okay. I'm gonna actually increase this guy a little bit. Okay, so we have sample data in HDFS my data directory. Now we are going to run the grunt shell in MapReduce mode. Okay, so you can just type pig because the default is MapReduce mode, or you can explicitly specify MapReduce. Okay, so I'm gonna just type pig, so it's gonna run it in MapReduce mode. Okay, so you can see because it's running in MapReduce mode, you can see it's connecting to Hadoop file system. Okay, and it's also connecting MapReduce job tracker. Okay, so that's basically connecting Hadoop file system here, and local domain 8020 and 8021 is the job tracker. Okay, so this is a grunt shell. Okay. All right, so you can actually run a few Unix-like commands within the shell. So you can even type pwd to actually see the current directory. So current directory obviously is HDFS directory, which is a user cloudra. And I can actually say ls, and it gives me all the directories and files on that directory. Okay. And then I want to actually see my data. So what do I have in my data? So I can say ls my data. And we have a Tom Sawyer big and Tom Sawyer small text files, which we have copied over a few minutes ago. If I want to see Tom Sawyer small text files, so I'm going to just do cat. Okay, so this is the small, this is the small version of Tom Sawyer text file. Okay. All right, so that's what we have done. And now what we want to do is, we want to actually have a word counting for this particular file. Okay, so we are going to run each of these commands. So we are going to run, so I'm going to just copy this code. I recommend you guys actually type if you can. Okay, so basically I am loading, so I'm actually loading Tom Sawyer small text file, okay, into, this is called the relation. Okay, so basically, by the way, it's not actually executing this line of code yet. It didn't create basically MapReduce code yet. The only time it's going to actually create the MapReduce job is either dump or store. So here, this is the lines lines. Now I'm gonna say dump lines. Okay, so whenever you say dump lines, basically you are asking pig runtime to execute, meaning you're asking pig runtime to generate MapReduce code and then run it. Okay. All right. So now you can see it's executing MapReduce jobs and all that stuff. Okay. So the result is gonna be something like this. So it's actually capturing each of those lines as what is called a tuple. Okay. All right. So let's actually and then so this is what we have. And then what we are going to do is, by the way, we are going to actually learn each of these commands in a bit more detail later on. I just want to actually show you what is, what is a pig statement look like when you are doing word counting. Okay. All right. So you can see, this is actually a MapReduce job. So this is the end result. Okay. All right. Now what we want to do is for each of those lines, we want to, since the this is a positional argument. So the first $0 means, so it will take each of this because each line has a single string. Okay, basically it will capture each of these and it will tokenize it. Okay, so what it does is it's gonna actually have each one of those as a separate tuple. Okay, all right, so we are tokenizing it. Okay, and then again we are gonna dump it, dump and tokenize. Oops. I hate this. Yeah, so whenever I do this, yeah, I'm losing it. So I have to start it again. Okay, so let me just start it again. Yeah, I'm gonna just copy. And then dump lines. And we tokenize it, and the result is going to be something like this. Okay, and then what we are going to do is we are going to flatten it. So when you flatten it, each of these field is actually the tuple will be unnested, so it will result like this. Okay, so I'm going to and then what we are going to do is we are going to generate. Oh, so by the way, the tokenize and flatten can be done in sequence like this. Okay, all right. So I might actually do that once this is done. Okay, so I'm gonna just run this guy. And dump words. And then we are gonna group these words, okay, by word. So the result is gonna be something like this. This is the group, and these any element that belongs to this group is gonna be actually listed like this. Okay. So that's the grouping. Again, we're gonna actually learn this grouping and all this for each syntax in a bit more detail later on. Okay, so I'm just showing you, how word count program could be written in PIG. Okay, and then we are going to count the words. Okay, all right. So this is done. So let me just do grouping. So I'm going to copy this guy, group, and then dump world group. Okay, and then the result is going to be something like this. Okay, so for each of those words, any instances of those words will be the value. Okay. Okay, so that is what we are going to see, and then we want to actually count. Basically we want to count of this guy. Okay, and then when you dump the count word, what you're going to see is something like this. So she occurs 3 times, Tom occurs once, things like that. Okay, and then we are going to order. Okay, based on the value. So this, positional argument 0 is actually representing this guy. So when you do this, what you're going to actually see is something like this. N occurs 10, the occurs 8 times, so it's in descending order. And then we are going to, instead of actually displaying all this, I want to display just 10 of those. So you can use a limit like this, 10. And then what you're going to actually display is just 10 of those. And then you can actually store the result into HDFS. Okay. So you can say, first of all, you want to actually make sure, the output directory is not present. So, you just remove the directory just for the sake of, you do not want to experience the error condition. And then you're going to say store limited. So this is the result into, and this is the output directory using PIG storage colon, that means delimiter. You want to use colon. Okay. So when you do this, basically this is the result. When you actually display the output file, this is what you are going to see. Okay. All right. Okay, so I am going to give you guys about 15 minutes to try exercise 1. Again, I don't expect you to understand the detailed syntax of each command in this PIG script, okay? As long as you get the sense of how things are being done, that's good enough. In the rest of the presentation, we are going to learn the syntax of those things in a bit more detail, okay? Let's talk about PIG Latin concepts a bit. So these are PIG Latin data types: field, tuple, bag, and relation. You can think of relation as a bag as well. So the relation is in fact the what is called the outer bag. Okay. So field is a piece of data. Tuple is an ordered set of fields, and the tuple is represented by parentheses. So you have seen examples like this: parentheses, 11 comma, John dot comma. So each of this one is field, and tuple is basically a set of those fields. So tuple, you can think of it as a row in relational database table. The bag is a collection of tuples. So the bag is represented with a brace. So in this case, this bag has two tuples. This is a tuple, this is a tuple. Okay. So you can think of a bag as a table in the relational database. Of course, bags do not require that all tuple contains the same number of data or same type of data. There is no structure. Okay. Relation is a bag, more specifically an outer bag. So you can think of relation is a kind of bag, and I'm going to explain the difference between outer bag and inner bag. Okay. In the following slide. Okay, referencing relations. So relations are the result of executing your PIG statement. So in this case, I have executed load the operator reading this text file using PIG storage. What it means is that it's providing a delimiter. So the default is a tab. Okay, as I'm reading each line as name and age and JPA. Okay, and the result of that is going to be captured as a variable like this, A, and this A represents a relation. So it's basically the collection of tuples. So if you dump A, you can see there are 4 tuples: John, Mary, Bill, and Joe. Each of these are tuples. Okay, so it's reading students.txt file and then create 4 tuples. That 4 tuples is a bag, and this A is actually sometimes called the relation. So anytime you are executing a PIG statement, it creates a relation, and you can think of it as relation is a bag, collection of tuples. Okay, schema data types. So it does support simple type like int, long, float, and double. And in terms of array, it does support char array or byte array. And complex data type, it does support this tuple, bag, and also it does support the map. Okay. So in our previous example, when we are reading a text file, I want to capture the first item as a char array, and age as int, and JPA as a float. So these are, char array, int, and float. Those are schema data types. Okay. And again, the tuple, bag, and map, those are also considered as data types. Okay, referencing fields. So fields are referenced either by positional notation like a $0, $1, and $2, or by name if the name has been assigned. Okay. So positional notation is indicated with this $sign and begins with 0. Okay, so let's say an example. Suppose we have this A relation that has these 4 tuples. Okay, now what I want to do is for each A generates. So you can think of for each generates like a select statement in SQL. So you're basically selecting a column. So here generate meaning I want to select name field and $2, that is the third positional field. So in this case, you can see this name, is actually explicitly specified as a reference to that field. So name. So in this case, when you dump it, you're going to see John, Mary, Bill, and Joe. Okay, and then $2 is the third field. So that is going to select these GPA values. Okay, so in this case, I'm just selecting the name and GPA fields. Okay, so this is how you're going to reference fields, either positional notation, or you can use a name if the name is specified. Okay. Referencing complex data type fields. So the fields in a tuple can be any data type, including complex data types such as bags, tuples, and maps. Okay. So in our case, suppose we have this data in this form. I'm just displaying the data file. So this is a text. Data is in fact a text file with these things. Okay. And what I want to do is I want to load this data as two tuples. So T1, and I want to read as a tuple data type. So the first one I want to read as a tuple data type, and the first one is going to be named as T1A. The second one is going to be named T1B. Third one is going to be named as T1C, and the tuple will be named as T1. And this tuple will be named as T2, and we are using T2A, T2B, T23, and things like that. Okay, so basically, what it will generate a relation like this. Okay. Now, when I referencing each of these things, I can actually use this T1 tuple and then a field. So this one is the name of the tuple, and this is the name of the field. This is the name of the tuple. Here I'm actually using positional notation. So in this case, when you dump X, it will just display 3, 1, 2 and 4, 3, 9, which is basically second tuple's first field. And this one is the name T1A, which is this guy. Okay. Okay, concept of outer bag and inner bag. Okay. So relation is typically outer bag. Okay. So as we talked about, A is a relation or bag of tuples. So when you have this, suppose if you have some data, numbers 1, and then we load it, and then we are getting it as F1, F2, and F3 int. So it basically it does have 4 tuples, and this A as a bag or relation has these 4 tuples. Okay. Now what we want to do is now we are going to use a group. So we want to group this A relation by F1. So F1 is this guy, right? So basically, I want to collect all the tuples that has 1 as a first. Okay, and this one 4. So I want to collect everything, every tuple as a value, and which has a 4 as the first number, and 8. So basically we grouped based on this number, and then we just have these things. So in this case, this is a bag, right, which has a single tuple. This is also a bag which contains 2 tuples. This one is a bag which has the single tuple. Okay, so this is a bag, and also this relation is a bag, right? So relation is outer bag, and these guys are inner bag. Okay, because these are tuples, each of these are tuples, so the collection of those is a bag, right? So this is outer bag represented by relation of X, and internally it does have its own values of each the tuple in this case could be also the complex type, such as the tuple or bag. So this is inner bag. Example of, so in this case you are seeing example of inner bag. Okay, case sensitivity. So the relation A, B, C, those are case sensitive. Names of the fields are case sensitive. Okay, PIG function names such as a PIG storage and count, those are case sensitive. However, the actual keywords operators like a load, using, as, group by, for each, generate, and dump. These are case insensitive. So here I have to actually use, A, B, C. Those are the case sensitive, but these load, group, for each, and dump. So that's the reason, when I was running dump, I was able to use the small letter. Okay, but if I use incorrectly, so if I say this capital W like this, oops. Let me just delete this guy. Yeah, then it doesn't find it, okay, because the names of this thing is case sensitive. Okay, all right. Let's talk about PIG Latin script operators and functions. So relational operators, so load, for each, filter, join, group, and all these things. So again, you're going to actually learn each of these in a bit more detail later on. It does provide arithmetic operators, plus, minus, multiplication, and things like that. Diagnostic operators is basically, describe, is basically displaying the syntax, the basically structure of that the relation. Okay, explain, illustrate, and dump. Dump is actually dumping the result. And we're going to take a look at each of these in a bit more detail later on. The functions, if you actually go to this website, it actually provides built-in functions, average, concatenate, count, and all that stuff. Okay, so those are the functions you can use. So eval functions, load and store functions. So PIG storage is basically the default. Bin storage, HBase storage. So we're going to actually play around the HBase storage when we are learning HBase. Math functions, absolute, random, and things like that. String functions and date and time functions as well. So it provides many built-in functions. In terms of Latin script structure, PIG script is made of sequence of PIG statement, and each PIG statement is made of relational operator, so like a load, an arithmetic operator, and functions. Okay, and the result of PIG statement execution is captured into a relation. So each of these, like lines, words, word count, count word, those are all relations. Okay. Okay, moving forward. PIG Latin script. You know what? I am going to stop right here, and we are going to actually continue from this point, because right now is the 3:27. We are supposed to be done at 3:30. So we are going to actually stop right here, and I will continue from this slide. Okay, so we were about to start PIG Latin script flow presentation yesterday, so we're going to start from here. So typical PIG Latin script file will contain these 3 different steps typically. So step number 1 is reading or load data from the file system. So if you see an example on the right, in this case, I'm loading student.txt file on the my data directory as schema of this. So this is called the read on schema. So you are imposing schema when you read the data. So again, this is one of the differences of the Hadoop from relational database. Relational database is the write on schema. Hadoop is read on schema. So this is an example. So the step number 1 is typically reading or loading data from the file system. And step number 2 is probably the bulk of your scripting language, script operations, is perform a series of transformation to the data using these operators like a filter, for each, group, join, union, split, sort. We're going to learn each of these things in a bit more detail later on. So for each tuple, in this case, for each tuple, select only name. So you are using, when you want to select a particular column or set of columns, you're using for each generate. So for relation A, we'd like to select only name column. Okay, so in this example, we are just using for each, but you could have a lot more transformations in a typical PIG script file. And the last step is execute and then display or save the result. In order to display, you are going to use dump command. If you want to save, you are going to use a store. So store, you can store the result into either HDFS or HBase. Okay. As I said, it is the dump or store that triggers the execution. So until you say dump or store, map reduce jobs are not going to get started. So in this case, we are going to just say dump B, and map reduce job is created and then executed, and result will be displayed. Okay, so typical PIG script file. Step number one, read a file, load data from the file system, and then perform a series of transformation, then either dump or store. So let's actually talk about each of these steps in a bit more detail from syntax perspective. So the load operator goes like this: load and the data, and then as an option, these are optional, using function and adds schema. Okay, so let's talk about each of these arguments for load operator in a bit more detail. So the data is the name of the file or directory in single quote. Okay. Again, if you specify a directory, then all the files under that directory will be read. Using function specifies a load function to use. So PIG storage is the default function. So if you don't specify using function, PIG storage is going to be used as a default function. Okay. Later on, when we are learning HBase, there is HBase storage function for reading data from HBase kind of things. Okay. So PIG storage is a default function. PIG storage could actually receive a couple of arguments. The first one is field delimiter, and then you could also specify some options. Now, the default field delimiter is a tab. Okay, but you can certainly customize with a regular expression. Okay, the last optional argument is as schema. So schema, this schema enables you to assign names to fields. You can assign names to fields and declare types for fields. So we have seen examples of this, okay, already, like this. Okay, once you have specified the schema, you can actually use the describe operator to view the schema. So this is one of the debugging tool that you can use. Again, we're going to learn about this one, describe operator, in a bit more detail later on. So let's see examples. Of load statement. Yeah, these are the same examples we have seen before. So here we use load, and we are reading student file or directory using PIG storage, and default is tab. So in fact, this statement and this statement, the second statement, are equivalent. Okay, the second statement doesn't actually specify using PIG storage function, but because this is the default, so these two are equivalent. Okay, and they are reading the data and the name and age. So it's assigned the names to the fields, and they also assign the types to each field. Okay, so name is going to be char array type, and age is going to be read as int type. Okay, again, these two are the same. Now, if I want to use a different field delimiter other than tab, then you can specify. In this case, I'm using comma as a field delimiter. Okay, so if you want to use a comma as a field delimiter, then you have to explicitly specify the function. In this case, using PIG storage function, so you specify comma as a field delimiter. Okay, all right. So that is load, the operator. And then step number 2 is the bulk of the operations of your PIG script. So here you are performing a bunch of transformations to the data. Okay, so you can use filter operator to work with tuples. You can think of them as rows of data. So you use filter operator to filter out tuples based on condition. Okay, so again, we are going to use examples of this one in a few minutes. You can think of it as a where clause in relational database SQL. Okay, for each operator is used to select out the columns of data. So this is used to select columns. Okay. Now you can also use the group operator for single relation to group data in a so group data. Again, we are going to see example of this one in a few minutes. Now with the multiple relations, we're going to actually cover these multiple relations in a bit more detail in part 2 presentation of PIG. So here we are going to just explain the general concept of these things. So use co-group, inner join, or outer join operators to group or join data in 2 or more relations. So if you have 2 or more relations, you can actually use these operators: co-group, inner join, outer join, or union to merge the contents of 2 or more relations, or you can use a split operator to partition the contents of a relation into multiple relations. Okay, so don't worry about this multiple relations operator for now, because we are going to actually study these things in detail in our the next presentation. Okay, so in step number 2, just remember, you are going to use a lot of the transformation operators to transform data. Okay, all right. So since we have been exposed to these operators, so let's actually learn each of these in a bit more detail. So relational operators. So filter operator is used to select out rows, or you can think of them tuples or rows of data. Okay. Again, if you want to select columns, you're going to use a for each and generate. Okay, so filter is commonly used to select the tuples that you want, or you can think of conversely to filter out the tuples you don't want. Okay, so let's see an example. Let's say we have relation A, which has these 6 tuples. Okay, and each tuple has 3 int type fields. Okay, so we have numbers to that data using this schema, and it's using here I should actually used so this is using comma, right, as a field delimiter, right? So I should actually have specify using PIG storage comma, otherwise it's going to use a tab as a default delimiter. Okay, so this example is in a sense incorrect. Okay, so just think there is a PIG storage and comma function here. Okay, all right, so assume the A relation has these 6 tuples. Okay, now if I want to choose only the tuples that whose third field value is 3, then I can say filter A by, and this is the condition. Okay, F3. In fact, this F3. I should actually use A3 because it is named. Okay, but F means it's a field as well, so field 3, this is okay as well. Okay, but since it already has a name, I should actually use the A3 as A3 to be more clear. Okay, so filter A, the third field value is 3. So in this case, there are only 3 tuples: this guy, and this guy. So those 3 tuples will be selected. Okay. This is another example here. In this case, I want to select tuples whose first field value is 8, or the second and third field, the addition of second and third fields is greater than the value of the first field. So because it's OR condition, it should actually have this 4. So obviously this 834 and 843 should be selected because the first field is 8, and the other 2 meet this condition. Okay, so filter operator is used to select tuples based on conditions. So you can think of this one is like select and where clause in SQL. Okay, for each generate. So this is used for selecting columns. Okay, you can specify the wildcard here. So in this case, I say for each A generate and star. That means A and X, they should have exactly the same number of tuples with the same values. Okay, because it select all the columns. Okay, so X and A, they are they should actually have the same tuples, same set of tuples. Okay. Now, if I want to select only the first column and the second column, okay, then I can use for each A generate, and then you specify set of columns that you want to select. In this case, I am selecting A1, A2. Okay. Assuming X is actually read into with this A1, A2 as a field names, then it will select the first two columns of X. Okay, it's pretty straightforward. Okay, flatten operator is used to unnest tuples as well as backs. Okay, so let's see, we have a numbers relation. Okay. If I dump numbers, this is reflecting the numbers relation. Okay, so it has three tuples, and each tuple has a back as a field. Okay, so this is a back. It has a single back. This one has a back that has two tuples. Yeah, so this one has a single back that contains a single tuple. This one has a back that contains two tuples, and this one has a back that contains a single tuple. So when you flatten so basically for each numbers. So for each numbers is that it will take each tuple and then generate number. The flattened number. What that means is going to flatten each the tuple. So the first one will be unnested, so it will just have 1 to 3 as a tuple. These two tuples are unnested from this line. Okay, so 421 and 433 tuples are unnested from this back, and the third one is again, it has a single tuple, and this one is unnested. Okay, if you happen to have another one over here, another tuple, then that should actually add right here. Okay, so that is flatten, and flatten operator is used to unnest tuples as well as backs. Okay, so again, this is we have seen examples of the flatten yesterday when we do word count pick the script. Tokenize. Tokenize split a string into tokens and output as a bag of words. Right? So again, we have seen this example yesterday as well, right? So let's say we have relation A. Okay. So basically, relation A is generated reading strings.txt file, and then is going to take each line as F1. Okay. So it will generate, let's say, 3 tuples. Okay, here is a first string, this is a second string, and this is a third string. Now, when you are using for each A generate tokenize F1, what that means is we are reading each line, okay, and then we are going to tokenize it. So the first string will be read, and it will be tokenized into a bag like this. Okay, and again, this second line will be read, and then it will be tokenized like this. Okay, all right, so that's tokenize function. Group operator. So group operator is the one that might confuse the most. Okay, but if you actually see example, it's not that bad. Okay, so basically, when you group a relation, the result is a new relation with the 2 columns. One is the group column, and the other one is the name of the original relation. Okay, and the group column has the schema of what you group by. So in our case, typically you are going to group by like an int, but you can actually group by with different type. You can even use another tuple as a group by schema. But in general, you are going to use like int, some simple type, as a group by schema. Okay, so let's example on the left. So we have created a relation reading students' data using this schema. Okay, this is an example of the describe. So when you say describe a relation, it will describe the schema. Okay, so basically it will display name, age, and group GPA with a float. Okay, so when I dump it, I have 4 tuples. Each of these tuples represent name and float. I'm sorry, the GPA. Okay, so now I want to group by based on age. So what I say was group A. So I want to take a relation. I want to use group by on age. Okay, so now if you say describe B, it will describe the schema. So you can see the schema says group int. So this is the group by the schema. Schema is int type, and this is the relation A. Okay, illustrate is used to describe the examples of this group by. So in this case, we have 18 and 20 based on age. 18 and 20, these are original. These are the tuples from the original relations. Okay, so these are just examples. Now when we dump B, by the way, illustrate is just the subset of the whole thing. Okay, now we want to dump B. So when you say dump B, on the left you can see the first column is in fact the values of age. So for age 18, there are 2 tuples that actually meets that group by the requirements. So John and Joe. Okay, both of them are 18. And age 19, there is only one person, Mary. And for 20, the Bill is the one. Okay, so again, when you use a group, when you use a group by, basically you are going to create the first column with the group, and then the back of all the tuples that meet that meets that group by the value. Okay, hopefully you got the sense of how group by works. Okay, let me see if you guys have any questions. Order by is pretty straightforward. So here, I have a relation A that has 6 tuples, and I want to order this relation based on third field, assuming A3 is a third field. Okay, so basically when I dump X, you can see tuples are rearranged based on the value of the third field. So 5, 4, 3, 3, 3, and 1. Okay. As far as these 3 tuples are concerned, which one comes first is not determined. It is randomly selected by PIG runtime. Okay. So if you want, in fact, have another order based on another column here, then you can certainly specify, the by A2 ascending or something like that. Step number 3. So once you have done a bunch of transformations using the operators that we have just learned, then you can trigger the execution. There are 2 commands, 2 operators that you can use to trigger the execution, dump or store. So as I said, no action is going to be taken until dump or store commands are executed. Okay, so basically before dump or store is executed, the only thing PIG runtime will do is basically parse and validate or analyze statement. So if you have in fact a syntax error, it will be detected. Okay, but it will not start the execution until dump or store commands are executed. Okay, so as I said, dump is for displaying the result on the screen and is used mostly during development time. And store is saving the result into HDFS or HBase. Okay, all right, so in our exercises, we're going to mostly deal with HDFS as the storage location because we have not learned HBase yet. Okay, so later on we are going to cover HBase today, and we should be able to learn how you can save data into HBase. Okay, so this slide actually shows comparison of PIG Latin statement with SQL or HiveQL. Yeah, so Hive is another technology in Hadoop ecosystem that actually provides very similar syntax to SQL. Okay, so let's actually compare PIG statements. So filter by is, you can think of, if you just go over here, filter is like a where clause in SQL or HiveQL. Join by is, we haven't learned the join by yet. Okay, so that's actually join statement in SQL. We're going to learn join in our next presentation. Group by is again group by in SQL, pretty similar syntax. And for each generate is select, is selecting columns. Okay, and you can also use a filter to reflect, group by and having. Okay, right. So group by and having are typically being used in SQL together, right? Okay. And order by descending or ascending is actually order by, the same syntax. Okay, all right. All right, so let's do exercise 4. So in exercise 4, what we are going to do is, in fact, try each of these operator in a bit more detail. Okay, so we are going to start PIG run shell in a local mode. Okay, for the sake of the simplicity of this exercise. First of all, I want you to go to sample data directory of this hands-on lab. Okay, so let me just copy this guy, and let me see. Okay, so let me just make sure that I am in that directory. Okay, so I'm in the sample data directory, and if you take a look at the files, we have a bunch of sample data. Okay, all right, so we are going to start in the local mode. So PIG -x local. Okay, all right. You can see it's connecting to local file system here, so you should be able to see it's connecting to local file system. Yeah, so right here, connecting to Hadoop file system, and this is actually connecting to local file system. All right, so now let's try the referencing relation. So if let's take a look at the contents of students data. So you say cat students data. We have these four students. I mean, we have four lines of string, and each line has a name and age and the GPA separated by comma as a delimiter. So this is a file, and what we want to do is we are going to read the students data file using PIG storage. Now we are going to use a comma as delimiter, and we want to provide read on schema. So I'm reading the first one as a name with a char array type, and age int type, and GPA float type. Okay, so I'm going to copy this guy. Again, I recommend you guys to actually type it instead of copying it. I'm doing right now. I'm actually kind of cheating a little bit. Okay, to just speed up the demonstration. Okay, so I have read students data, so now I can say dump A. Okay, I cannot say A small letter because A relation should be the case sensitive. So if I try like this, it says unable to find operator for alias A. Okay, so you should say A like this. Okay, so now is generating it's creating map reduced jobs, and then it should actually display the results. So we have created a relation that contains 4 tuples. Okay. All right. Now that's what we have just did. Okay. By the way, you can actually find out the aliases. Okay. So yeah. Not a big deal. Now we are going to referencing fields. So what we want to do is we want to just display only. We want to create a relation that contains only the name and the JPA. So we are going to actually use name as explicit name, and then we are using positional notation. So $2 means it's a third. The third field, right? So in this case, it will just display. I'm going to just demonstrate a couple of things, and I'm going to let you actually do the work. Okay. So here, and then if I dump X, and it again creates a map reduce jobs, and it will display 4 tuples with this. Okay. So if I want to actually do just in this case 1, then it should display the tuples with name and why it did it's interesting. It's what did I do? Yeah, so I actually expected age to be displayed, so this is actually interesting. So let's maybe it's because the okay, so let me see. Age is still dump X. Okay, so X is still okay, so that is correct, but I say I want to actually make sure that A is still the 4 tuples with all the values. Dump A. Okay, that's cool. So now I want to create X, A, and the name. And I want to select positional argument 1 like this. Oops. Oh, maybe actually it didn't really change. Okay. Yes, that's why. Yeah, I want actually. Yeah. By the way, let me just show you. If you do not actually have a correct syntax, this is the. It will validate it and let you know that syntax is incorrect. Okay. So I'm going to type it for X equal. For each A generate and name and comma $1. So I'm selecting first and second field. Okay, and dump X. Okay, so that worked. Alright, so that is referencing fields using, in this case, name or positional notation. And yeah, so this is actually complex type field. So this is something that we learned yesterday, right? Okay, so I'm going to let you try it. Inner bag and outer bag. So again, this is something that we tried yesterday, right? Okay, so I'll let you try it. And this is filter. Okay, so we have numbers 2. Which has this 6 lines of strings, okay, and then we are reading this data using PIG storage, and again we are using comma as a delimiter, and we are using this schema. So we are reading 3 fields, all int type. Okay, so when you say dump A, you can see it creates 6 tuples. Okay, and then we are just selecting tuples whose third value is the 3. Okay, yeah, so these are exactly the same code we have learned from the presentation. So I'm going to just speed things up, and I'm going to actually let you do, let me see. So this is flatten, and we can group by, and then we are generating one as number, and then we are using for each, and this is tokenize, and this is a group. Okay. So let me just explain group operator one more time. So we have students data, okay, and then we have read students data file using pig storage comma as a delimiter and name age. Yes, so this is exactly the same. So now when you do, you know, the let me just do this. Students A, and then we are going to read into A. Yeah, so this is the same code actually. And now if you say describe A, you can actually see the schema of the relation A. So it actually describes name, age, and GPA float. Okay, and now if I say dump A, it should actually have these 4 tuples, right? Okay, so now I want to group the relation A and age. Okay, so I'm going to say B equal group by group A by age. Okay. Okay. Now again, if I say describe B, it should give me a syntax. So again, you can the syntax schema, I should say. So is you know, the first one is a group, which is in type, and then you know, the value of it is in fact the relation. Okay. All right. So now if I say dump B, it will display you know, this age as a group, and then it should have all the tuples that are grouped by that age. Okay, so I want you to do some, you know, your own experimentation. Try to group based on, for example, you know, in this case GPA. Okay, or even, you know, yeah, so you know, even by like anybody whose first character of the name start with a J or something like that. Okay. All right. So that is group by, and order is again same thing that we have learned. So this is same example in the slide. So okay. So I am going to give you guys about 15 minutes to do this exercise. Again, I strongly recommend you to do lots of your own experimentation. Otherwise, you're not going to learn that much. Okay. All right. So 15 minutes. Okay, the next topic is PIG Latin diagnostic operators. We have seen these diagnostic operators already. So there are 3 diagnostic operators you can use. Describe displays the structure of the schema. So that's something we have already seen how it works. Illustrate shows how PIG engine transforms the data. Okay, so you know, basically suppose you have load myfile.txt file using tab as a field delimiter. We have relation A, and this is the schema using describe A, and illustrate A is supposed to actually describe, you know, how it actually ends up this. So initially it's going to read as a byte array, and then it's going to convert to int. Okay. Yeah, unfortunately, the lab exercises doesn't work. I think it just have some issues. Actually, I shouldn't say lab exercises. The Cloudra virtual VM, the Quick Start VM is having some issues with this. Okay? So anyway, so we can actually try that. Explain produces the various reports: logical plan, physical plan, and map reduce plan. So basically, when you run you know, when you create a relation, and then when you say dump or store, it will actually create map reduce jobs underneath. Okay, and basically PIG runtime will go through logical plan and physical plan and map reduce plan. Okay, so you don't really have to understand, how it is done underneath, but, for some people, trying to find out what's going on, this might be actually useful information. Okay, so we are going to actually try it out, see what it gets displayed, but we're not going to actually dive into, understanding this logical plan and physical plan, map reduce plan, all that stuff. So that's pretty much what the PIG runtime does underneath internal operations. So it's not that much of a big interest to us. Okay, so we're going to just try explain, but we're not going to actually digest each of those logical plan, physical plan, and map reduce plan. All right, so let's do exercise 5. So let's go to exercise 5. Okay, so we're going to try describe first. Okay, let's actually try the map reduce mode instead of the local mode. It shouldn't matter, but so we can actually start with the map reduce mode this time. Just try to, the exercise both local and map reduce mode. Okay, now we are going to read Tom Sawyer small text file without giving any schema. Okay, so we read this guy. And now, if you try to describe lines, it will say schema for lines unknown. Okay, and that's expected because we haven't given any schema. We don't schema. Okay, so now we are going to give a schema when we load. So this time I want to read as char array. Each line will be read as a char array. So now let's try to give. Okay, now if I try to describe schema, it should give me schema because we have load the data using this schema. Okay, all right, so that is described, and now you are going to try, this is word count exercise, and we are going to actually see the schema after each the line of statement. Okay. So in this case, when we actually do flatten tokenize char array as word. So basically, the schema is char array. By the way, if you don't actually specify the type of it, then it's going to be as a default this char array. Okay. All right, and then this is group words by word. So when we describe word group schema, then what you're going to see is, again, it will display group, first column, and then words. Okay, so this is something that we have exercised in exercise 4 as well, right? In our case, in exercise 4, we have grouped based on age, so that should be grouped like an int type. This time, you can see we are grouping based on word, which is a char array type. Okay, and then we are doing generate count and group. Okay, so basically we are selecting 2 columns. One is count, and the other one is a group. Okay, so in this case, when we describe count per word, you are going to see the long, and long is first, and then group is the second column. You can certainly actually switch this guy and see what happens. In this case, you're going to see group first, and then you're going to see count next. Okay, so basically you can arrange whatever columns you want in the order you want. So in this case, we just want to display. We want to get the count first, then group. Okay, and this one is order by, so it should actually have the long, and so this is long is representing the value, and this is a group. Okay. Okay, so let's try to explain. Yeah, so I should, so when you do explain, okay, you're going to see logical plan and physical plan, and then map reduce plan. So this is what PIG runtime does underneath. Okay, all right. Again, it's not, we're not gonna actually go through these things. Okay. All right, the last one is illustrate, and this is the one that that might not actually work. Okay, so suppose let's actually try. I'm gonna just try this, which is small. Oops. So I am going to copy this guy. And I couldn't actually reduce this guy. Okay. And if I say dump widget, just to see. I hate this. I can actually reduce this guy. Man. Yeah, okay, so somehow yeah, so I think I'm not in the actually in the right directory somehow. How can I minimize this guy? Stupid. Anyway, I'm gonna actually explain you guys first. Yeah, somehow when you perform illustrate, like illustrate number user visits or something like that, you're going to actually experience internal error creating job configuration. So I think it is a bug in quick start VM. Okay, but if it worked, it should actually give you the how it actually ends up there. So the idea is this: suppose if you have performed the multiple transformation. So we have created the visit relationship, and then we have performed the filter, and then we have grouped it, then we have performed for each. Okay, so we have performed like 3 or 4, in this case 3, transformation. Now, if you say, if you say at this point, illustrate num visit. Basically, what is supposed to happen if it worked is it actually goes through each of those transformations. So, it's basically starting from here, then it goes over here. So basically, it displays the visit, recent visit, and user visit, and number of visits. So it will actually go through, examples of the transformations from the beginning. Okay, so you can see how things have transformed for each of these transformation, and it gives you a good description on what is going on. So it's a nice debugging tool. Unfortunately, it's not working in the quick.vm. Okay, so let's just try that out. Okay, all right. So I'm gonna give you guys about 10 minutes to try this out. And let's have 10 minutes break as well. Okay, so let's get back in 20 minutes. Now we are going to look into several a bit more sophisticated PIG examples next. So here we are going to look into 3 examples. The first one is find most popular first word in words. Okay, so we're going to read a text file, and then we are going to see which first letter, which letter is in fact the most popular first letter in those words read from the file. Okay, pretty simple one. The next one is finding maximum temperature in a year. Again, we have weather data, which contains, this is actually the same weather data file that we have used yesterday. It does have year and then a date and the temperature of that date. Okay, and we like to actually find maximum temperature for each year. Okay. This is the same exercise we have done in MapReduce, and now we are going to rewrite it using PIG. Okay, and the last one is compute group averages. So we have, so I'm going to actually move forward using the lab documentation. Okay, so let's take a look at the first one, and so the first one is count. So count starting letter of words, and which one is the most popular one? Okay. So we are going to go again. We're going to go to sample pigs and directory, because we want to just execute it. Okay. And so make sure you are in that pigs directory, and you see we have a bunch of pig script, and we have some data. So the data postfixed as .data, and the pig scripts are provided as pig extension. So if you take a look at the start letter count, so start letter count. Okay. If you take a look at the contents of it, so basically what we want to do is we want to read Tom Sawyer small text file, and we are going to read as a line char array. So we are going to create a bunch of tuples. Each of those tuples represent a line of the text file, and then we are going to tokenize the provide text into words. So this is pretty much the same thing that we have exercised yesterday up to this point, and then we are going to retain the first letter of each word. So basically for each words we are going to create the letter. We are going to create the letter, and the letter is going to be the first one of each word. Okay, so this is the word. We are using substring function, and for each word we are just taking the starting point 0 and starting point 2. Okay, so now we collect letters. So if you dump letters, you're going to see the single letter, letters as tuples. Okay, and then we are going to group by letter. So we are going to group by letter, meaning for letter A, we are going to see all instances of letter A. So I want to in fact dump at this point. Add a dump the statement here. Okay, and see what gets displayed. Okay, so we grouped by letter, and then we are going to count the number of occurrences in each group. So basically again, we are going to specify generate group, and then the count of letters. Okay, so so now we should actually have, for each group, let's say letter A, we are going to see occurred. Okay, and then we're going to just order by, and then we are going to display just 5 of those, and then we are going to display. Okay, so when you in fact run it, okay, so let's just run it, pig, and we're going to just say dash local and specify the script. Okay. And okay, so now the unable to open operator failures result, failed to read data. Oh, okay, so it's actually somehow reading from the HDFS. Okay, so I'm certainly not actually okay, yeah, so instead of X local, I'm gonna just use do I have it in? Okay. Yeah, the PIG file is a local file system. Okay, but the actual input and output are coming from the HDFS. And you should observe the result of this. So A occurs 29 times, T occurs 19, H occurs 17. So these are only just top 5. Okay. Yeah, 12% done, 25% done. And I want you to do again some experimentation. So you want to actually edit the PIG script file, and you want to actually dump or you want to actually see the schema, and if things are not clear, you want to actually display the schema, and you just basically add dump counter per letter in the script file, and you can just rerun it and see whether the dump is actually displaying the things you expected. Okay. All right, so I think it's still, yeah, so now it's actually doing okay, so 37%, 50%, yeah, it's kind of slow. Anyway, so that is the starting letter count PIG file. The next one is maximum temperature for year. Okay, so we have a very simple text file. Okay, for the sake of this exercise, so we want to copy test data into HDFS. So we are going to use copy from local, and we just copy into my data, and then we are going to use again a sample. Yeah, so we're going to actually study the max temperature.pig file, and in this case, if you take a look at that, we are reading temperature text file as year, temperature, and quality. So this is read as year, temperature, and quality of the data, or something like that. Okay, and then we are going to filter records by temperature 999. Yeah, so so if basically we want to filter out any record whose the temperature is not in the form of numbers, okay, and the quality has to be one of these numbers, okay. So quality in this case all 1, so they are all qualified, okay. And then we are going to group filtered records by year. So we're gonna have the first column is going to be year, and then we have all the records, and then we are going to find the max value. Okay, so when you dump it, you are going to see result of this. So 1949, the highest temperature is 111, and for 1950 highest temperature is 22. So this is exactly the same logic we have exercised and map reduce case, but this time we have written in PIG. Okay, so let me see the result. Yeah, so this is the result I just got. Okay. All right. The 6.3 is compute group average. Yes, this is a little bit sophisticated. So let's say we have people data. So we have a name, and we have where, the country, and then we have gender, male or female, and we have 3 males and we have 2 females, and then we have favorite sports. So 3 people like football. All the males in US like football here, right? Okay. Mary in UK like baseball, and Ellen also like a football. And this is the last value is height of that person. Okay. So we want to find out the things we want to do is, for example, compute the average height for people of a given gender. So we like to actually, find out the average height for female and average height for the male. Okay, so that is this logic. So we are going to group people by gender, and then we are going to run for each. Okay, so basically, we are going to create average height. Okay, and we also can find out how many people there, and we actually group as gender. Okay. The next one is we want to compute the average height for people of a particular gender who played a particular sport. So we like to find out, for female who like football, what is their average height? We like to know all the males who like baseball, what is their average height? Okay, kind of things. So here we are going to group by gender and sport. So this is a case that we are in fact using two different columns as a group. Okay, and then we are going to generate again. Here we are, we have this average height and count. Okay, and then here we have a flatten as gender and sport. Basically, we want to display gender and sport. So if you actually run it, this is the way that we want to actually display. Okay, I want you actually kind of, take this out and see what happens. Okay, as your experimentation. Okay, all right. So that is 3 PIG examples that give you a sense of how PIG is actually being used in a little bit of more real life situation. Okay, so I'm going to give you guys about 15 minutes to try this exercise 6. Okay, again, I'm hoping you guys do a lot of experimentation of your own. Okay.